All right, I'm going to go ahead and continue with the examples that we didn't get to in class. So problem number 6 here. This one requires 2 levels of our integration by parts. So first off, we're going to go ahead and look at the problem as it stands right now. And I see that if we think about Liate with our logarithms, inverse trig, see Liate, algebra, trig, exponentials, we would want to do the algebra as our u, and so then our sine x dx should be our dv. So I'm going to go ahead over here. So it's going to be a little bit of side work happening over here. I'm going to have my u equal to x squared and dv equal to sine x dx. So du would be 2x dx, and then going back to v would be negative cosine of x, right? Yeah. Okay, so I'm going to go ahead and say that my integral here would then be equal to uv, so it'd be x squared, or rather I have the negative on the cosine, so I'm going to pull that out front, negative x squared cosine of x minus integral v du, so that'd be negative cosine of x times 2x dx. I'm going to simplify that just a little bit, so negative x squared cosine of x, and then that's going to be, I'm going to pull out the negative and the 2, so that should be plus 2 integral of x cosine of x dx. All right, so didn't quite get down to our full at a place where I can integrate yet, but I can go ahead and do another layer of integration by parts here, but because I see, okay, if I pick that as my next u, then that will differentiate down to 1, simplifying my integral to a place where I should be able to then get a final answer. Now I used u and v already, so I'm going to go ahead and use a and b here. So I'm going to say that's going to be a is equal to x, and db is going to be cosine of x equals cosine of x dx. So dA is going to be just 1 dx, and then going back, b is equal to sine of x, and now I should be able to continue. So that should be negative x squared cosine of x plus 2, and I'm going to have this in brackets because I'm going to 2 times all of this. And so I'm going to have a times b, so that's going to be x times sine of x minus the integral b times dA, so that should be 1 times sine of x, so just sine of x dx. And so I have negative x squared cosine of x plus 2. I'm going to go ahead and write this as 2x sine of x minus 2 integral. Actually, I can go ahead and take the integral. Integral of sine of x should be negative cosine of x. And I just need to remember my plus c at the end. So final answer would be negative x squared cosine of x plus 2x sine of x plus 2 cosine of x plus c to get to our final result at the end. Again, using 2 layers of synthetic division. All right, let's go ahead and look at problem number 7. All right, so this one takes our idea of integration by parts and throws in bounds. So let's go ahead and see how that would work. First off, Let's do our integration by parts. I see a natural log. So I'm going to go ahead and pick that as my u. Again, a little bit of work here on the side. So my u is going to be my natural log of x. So then dv is going to be x squared dx. And that's just following my Liate and hoping that everything works out as it should. So that should be 1 over x dx. And then v, taking my integral backwards, should be x cubed over 3. All right, so let's go ahead and do our first set of stuff here. So u times v, and then v du. So that should be, let's see, 1/3 x cubed, natural log of x, minus the integral of, let's see, so that should be x cubed over 3 times 1 over x dx. Now, before I move further, I want to go ahead and note what we need to now do with our bounds. Since I've already taken I have a complete part, a complete antiderivative, I do have to do the bounds for this part here, so 1 to e. So I want to do my bounds for that part, and I still have my bounds on that integral. So let me go ahead and start simplifying things and taking the integral, and then we'll go ahead and start doing our integral and everything. So I'm going to go ahead and rewrite this just with the bounds as is. So I want to simplify that integral and take the integral. So here, hopefully we can see that that becomes 1/3 the integral from 1 to e of just x squared. Something definitely easy enough to simplify there. So we're going to have the integral from, or rather, not the integral anymore, so 1/3 x, natural log of x. And I'm going to have 1 to e, and then that's going to be minus 1/3, and that should just be x cubed over 3, and that will also be from 1 to e. Now, since it is a definite integral, then I do not have, I don't have to do the plus c. So let's go ahead and plug everything in and see what we get. So we should have 1/3 times e, natural log of e, which natural log of e is just equal to 1. And that's going to be minus 1/3 times 1, natural log of 1, which natural log of 1 is 0. And then that's going to be minus, so I can actually erase part of my line over here. So that's going to be minus 1/3, or actually I can bring out that third, so that's going to be 1/9, and that's just going to be e cubed minus 1 cubed. All right, so then that's going to be e over 3, I'll just write that 1/3 times e. Natural log of e is equal to 1, so I just have that times 1, minus 1/3 times 0, minus 1/9 e cubed, and then that should be plus 1/9. So final answer, 1/3 e minus 1/9 e cubed plus 1/9, and we have our value. All right. Okay, so let's go ahead and look at this one here. So this one is number 35 from page 335, or 535 from the book, which will be very similar to number 37 on your homework. So if we follow Liate, then we would want to choose exponential is last. So I'm going to go ahead and use u equal to sine of x, du equal to cosine of x, dv is going to be e to the 2x dx. So going backwards, v would be equal to 1/2 e to the 2x. All right, so let's go ahead and see what we have. So that is equal to 1/2 e to the 2x sine of x minus the integral from let's see, v du, so that should be, oh, I forgot my dx there. So I got that, so that should be 1/2 e to the 2x times cosine of x dx. All right, so we have 1/2 e to the 2x sine of x minus 1/2. Yeah, just go ahead and do that. So 1/2, and then that will be e to the 2x cosine of x dx. And really, if you look at this, it's not much better than what we had. But let's go ahead and try another layer of integration by parts. So I'm going to go ahead and have I'm going to use that a and b. So a equal to cosine of x db equal to e to the 2x dx. So dA is negative sine of x, and b would be 1/2 e to the 2x. All right, so I have 1/2 e to the 2x sine of x minus 1/2 times 1/2 e to the 2x minus, oh no, cosine of x, forgot that part, cosine of x minus the integral 1/2 e to the 2x times negative sine of x. Again, I forgot my dx there, dx. All right. So let's simplify and see what we have. So 1/2 e to the 2x sine of x minus, I'm going to multiply my 1/2 in, so that should be 1/4 e to the 2x cosine of x. I can pull out my 1/2 and distribute in, so I should have minus 1/4. Oh, that actually becomes positive because of the negative right there. E to the 2x sine of x dx. That really doesn't seem to take us anywhere, but I want you guys to notice what we have. It's the same thing. So whenever we have like a trig, like sine and cosine and an exponential e to something, sine and cosine hop back and forth between each other, and e to the x stays e to the x regardless of what you do with it. But since sine and cosine hop back and forth between each other, eventually you should end up with something here that is identical to what you started with. And that is the key to fully completing this problem. So what we do is we say, all right, what we had originally, the integral from e to x sine of x dx, is equal to this big whole long thing here. It's 1/2 e to the 2x sine of x minus 1/4 e to the 2x cosine of x plus 1/4 integral of e to the 2x sine of x dx. And since, as we have noted, this is identical to this, I can actually move it to that side and combine it. Bind it together. As so. So I'm going to have minus, I'm going to minus this whole 1/4 of this integral. to both sides, minus 1/4. E to the 2x sine of x dx. And again, since those two integrals are identical, I can go ahead and, well, combine them. So we can think of this as being 4/4. 4/4 minus 1/4 would give me 3/4 of that integral, e to the 2x sine of x dx, equal to what I had remaining. So 1/2 e to the 2x sine of x minus 1/4 e to the 2x cosine of x. And then all we need to do is multiply by the reciprocal, multiply everything by 4/3 to get this integral by itself. And so finally, the integral of e to the 2x sine of x dx is equal to, let's see, 1/2 of 4/3 should be 2/3 e to the 2x sine of x minus 1/4 of 4/3 should be 1/3 e to the 2x cosine of x. And then, since this was an indefinite integral, we just need to remember r plus c at the very end. All right, so that is a crazy problem there, but that is how it is worked out. Hopefully you're able to kind of follow along, coordinated as we went. But yeah, let's go ahead and do that last problem, and then we should be good. So, thankfully this one is not nearly as crazy as that last one, but we have a table with f prime g, and g prime, select values, and we have this here. So we have the integral from 0 to 1 of f prime of x, g of x, dx, telling us it's equal to 5. It's good to know. And then we have this here. Well, the integral from 0 to 1 of f of x, g prime of x, dx. So following our ultraviolet voodoo, if we will, we're going to have f of x, so u is f of x. dv is going to be g prime of x dx. So du would be f prime of x dx, and v would just be g of x. So we go ahead and follow our normal pattern, and we would have f of x times g of x, but again, we have to do that in our bounds, 0 to 1, minus the integral from 0 to 1 of g of x times f prime of x dx. But we were already told what that is right here. That is 5. So all I have to do is really evaluate what this is here and then subtract 5. And we're good to go. So we're going to have f of 1 times g of 1 minus f of 0, so top minus bottom, g of 0, minus, and then we already said that that whole thing is 5. So f of 1 is 4, g of 1 is 3, minus f of 0, 2, g of 0, negative 4, minus 5. So that is 12 plus 8 minus 5. So 20 minus 5, so 15. So E. All right. And that finishes out our problems for integration by parts. Thank you for watching.